The world of physics I feel is overlooked. That's why I think this project is cool, because we're able to take anything we wanted, from singing to baking to sports, and find the physics. Physics is applied in almost all aspects of the world. This project was a window into the world and the eyes of physics. For my project, I chose to focus on the physics of motorsports. Motorsports have a lot of different ways in which physics is applied, from Newton's laws to impulse and even centripetal force. Physics is the driving force behind the thrill of motorsports. I'm going to focus specifically on 6 areas where physics is applied in racing: Newton's laws, engines, centripetal force, safety, aerodynamics, and friction. An object in motion stays in motion unless acted upon by an outside force. For racing, this applies in several aspects and is crucial for understanding how race cars handle turns, accelerate, and decelerate. Control is essential for optimal racing. The art of control can be described in weight transfer. When the car brakes, the weight is transferred from the back wheels to the front wheels. This is caused by the inertia that wants the car to continue moving forward. The most crucial and key part of weight transfer is in steering, specifically turning. Oversteer and understeer are both caused by inaccurate weight transfer. During hard cornering, the weight shifts to the outside tires, which increases the load on the front wheels. If the tires lose grip because of this increased load, the car will tend to understeer. This is also apparent in braking. When the car's front tires lose grip in braking, it also leads to understeer. Then there's oversteer. When entering a corner, if the driver lifts off the throttle or brakes, it leads to excessive weight transfer to the front, and ultimately the rear tires will lose grip, leading to oversteer. The law of acceleration. Engineers strive to and are continuously trying to improve race cars. The ultimate goal is to increase the acceleration. So by decreasing the mass, for example, by using a smaller yet efficient engine, they can produce the desired acceleration increase, providing faster starts and corner exits. For every action, there is an opposite and equal reaction. This law is apparent in the movements of the drivers. We can see it applied in the G-force that drivers experience. G-force is a major component when it comes to racing. As the drivers accelerate, decelerate, or turn, they experience G-force. When accelerating, the car moves forward while the drivers move back. The opposite happens with deceleration. When a driver turns, their bodies are ultimately pushed in the opposite direction with the same amount of force that was generated in the turn. Engines convert chemical energy into mechanical and kinetic energy that moves the car. There is a force that is developed by the combustion of gases within the engine. This process is done with the help of pistons and crankshafts. The movement of the pistons, due to the expanding gas, is converted to rotational movement because of the crankshaft. The rotational motion created is then transferred to the wheels. Centripetal force can be seen in racing during cornering. As the car drives along the curved path, there is a force that is typically due to the friction of the tires, which is keeping them in that general circular motion. When a car has a lower center of gravity, it helps to distribute the centripetal force more effectively, overall improving the stability during cornering. A main feature of safety in racing is barriers or crumple zones. These crumple zones are meticulously designed to absorb the force of impact during a crash. The crumple zones ultimately aid in generating a lower impulse, which is crucial for decreasing the force applied to the driver. There are ultimately 3 things that aerodynamics include: drag, downforce, and airflow. Drag is air resistance that slows the car. Being able to minimize the drag in aerodynamics is crucial for high speeds and control. Downforce, which is generated by wings or spoilers, pushes the car into the track, which increases the grip and the ability for high-speed cornering. Airflow affects stability and performance. Optimizing airflow and being able to direct the air to specific areas aids to maximum downforce and minimum drag. Friction is crucial in racing. It provides grip and traction between the track and the tires. It allows for acceleration, turning, and braking. Traction can be maximized by downforce and tire design. Friction is also another leading component of weight transfer. Each detail of physics is closely and intricately intertwined. They all build off one another and work together in unison to produce the perfect performance. Without physics, motorsports would not be possible. Without physics, the world would not be possible. Each intricate detail of the world has some form of physics. Physics is the building block of life. Without it, we would not exist, which is why I'm so grateful for physics. If it weren't for physics, I would not be doing this project talking about physics, because I probably would be off floating in space somewhere due to a lack of gravity. But even then, that is still physics. So I would, like I said, not even exist.